हाय फ्रेंड्स, आपका यूट्यूब चैनल में स्वागत है। नाउ वी आर डिस्कसिंग अबाउट मोशन ऑफ क्लास 9th. नाउ समथिंग अबाउट दैट think and act. Do you feel the necessity of to study the erratic motion, that is motion produced by tsunami of some objects, and learn to control them? Rest. If the position of an object does not change with the time passes with respect to surroundings. Example: a book kept on table. Motion. It is the change in position of an object with time with respect to surroundings. Example: a man sitting in moving train. Relative motion. When any object is at rest with respect to one thing and in motion with respect to some other thing at the same time. Example: when two trains A and B moving in same direction with same speed, then the passenger of A is at rest with respect to B. Position of a particle moving along a straight line. To describe the position of a particle at a given time, we have to specify first its distance from the origin or reference point. B. Whether it is in positive or in negative direction as seen from the origin or reference point. Now we have some questions as: an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. I have provided answer as: let an object travel from point A to B and then from B to A. In this case, total distance traveled is the sum of AB plus BA, while the displacement of the total of displacement becomes 0. Second question: a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Now, answer is as farmer covers 4 sides of this square in 40 seconds, because one side is 10 centimeter, so perimeter is equal to 4 into a side, that is 40 meter. Now 40 meter in 40 seconds. In 2 minutes 20 seconds, that is 140 seconds, he will move 3 times the perimeter of a square 120 seconds, and displacement will be 0. Thus, total displacement in 20 seconds is equal to root under 10 square plus 10 square, this 10 square and this 10 square, that is 10 root 2 meter. Third question: which of the following is true for displacement? It cannot be 0. Its magnitude is greater than the distance traveled by the object. Both the given statement is incorrect. Distance traversed and displacement. Distance. It is the actual path length traveled by an object is called distance. It is a scalar quantity and it has magnitude only. It has no direction. As I have provided the figure, now you can see. Example: motion along curved path. Displacement. It is the shortest distance between 2 points is called displacement. Displacement is a vector quantity It has both magnitude and direction. Yes, you can see it is a straight line. Now, example, a straight line distance. Now, a scalar and vector quantities. A scalar quantity. A quantity that has only magnitude is called a scalar quantity. Examples are mass. It has no direction because we cannot say mass 5 kg in east, 2 kg in west. Length cannot be determined. It has no direction because length may be in any direction. Time, say volume, density, electric current. Yes, you may confuse, but electric current is a scalar quantity, etc. Now, vector quantity, a quantity that has magnitude as well as direction and follows triangle law of vector addition is called vector quantity. Some examples are displacement, because if any object displaces, it has direction, it has certain direction and displace in that particular direction. Velocity, velocity is equal to displacement by time, and so displacement is vector, so it is also vector. Acceleration is also vector quantity. Force, that is we give force to some object in particular direction, so it is also vector quantity. Uniform motion and non-uniform motion. Uniform motion, equal distances traveled in equal time intervals, is called uniform motion. Non-uniform motion, unequal distances traveled in unequal time intervals, is called non-uniform motion. Now, after this, the term speed came. That is, the speed of an object is the distance covered by it per unit time, and formula is v is equal to s denotes displacement by time, and displacement is equal to velocity into time. SI unit of a speed is meter per second, and its CGS unit is centimeter per second. Now, velocity. Velocity, it is the speed of an object moving in a definite direction, and it is vector quantity we have discussed earlier. Now, average velocity is equal to initial velocity. Generally, it is represented by u plus final velocity, it is represented by v, and upon 2 divided by 2. And mathematical representation is as average velocity v is equal to initial velocity plus final velocity by 2. Now we have some questions. Distinguish between speed and velocity. Yes, you can see this is the definition of speed and this is the definition of velocity. Now, second question. Under what conditions is the magnitude of average velocity of an object equal to its average speed? And the answer is when the object moves along the straight line. Now, third question is, what does the odometer of an automobile measures? Odometer means distance covered, which measures distance covered, and other is a speedometer, which measures speed of the automobile. Third question. Now this is fourth question, but I have written third, so it is fourth question. What does the path of an object look like when it is in uniform motion? That is, it will be in a straight line. Equation of motion is applicable only for uniform acceleration. You have to remember this fact. That is, equation of motion is applicable only for uniform acceleration and do not for non-uniform acceleration. Question number 4. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of a spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 to the power 8 meter per second. Time t is equal to 5 minutes is equal to 5 into 60 seconds is equal to 300 seconds. Speed is equal to v, that is speed of light is equal to speed of light 3 into 10 to the power 8 meter per second. Distance is equal to velocity into time. Velocity is 3 into 10 to the power 8 into 300 meter, that is 3 into 3 10, 9 and 10 to the power 10 8, and this is 10 to the power 2, and we know in multiplication if base is same then the power is added. So 9 into 10 to the power 10 meter is the total distance. Now acceleration. Acceleration is a rate of change of velocity per unit time is called acceleration. Acceleration is equal to change in velocity by time taken. If velocity changes from an initial velocity u to the final velocity v in time t, then acceleration is equal to final velocity v minus initial velocity u divided by time. We have some questions as when will you say a body is in uniform acceleration, that is, and the definition is as uniform acceleration when the body travels in a straight line and its velocity increases or decreases by equal amounts in equal interval of time, then the body is said to be in uniform acceleration. Now listen again. When the body travels in a straight line and its velocity increases or decreases by equal amounts in equal interval of time, then the body is said to be in uniform acceleration. Example, freely falling of body. Second, non-uniform acceleration. When the body travels and its velocity changes at a non-uniform rate, then the body is said to be in non-uniform acceleration. Example, a moving car with variable speed. Now, question number second. Bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Now, initial velocity is given as initial velocity u is equal to 80 km per hour, and we convert it into meter per second. That is, as we know, we use 5 by 18 to convert kilometer per hour into meter per second. So we multiply 80 km per hour with 5 by 18 to convert it into meter per second, and by after calculation we obtain 200 by 9 meter per second, and final velocity v is equal to 60 km per hour, and same we multiply 60 into 5 by 18 to convert it into meter per second, and we obtain 150 by 9 meter per second. Now acceleration is equal to a is equal to v minus u by t. Final velocity is 150 by 9 minus initial velocity is 200 by 9 into and divided by time, that is 5. Yes, we have forgotten some sign, so here it will be in it will divide the change in velocity. This is v minus u is the change in velocity. So after calculation we will obtain minus 27.77 meter per second square. A train is starting. Third question is, a train is starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. Speed is equal to 40 km per hour. Time is equal to 10 minutes. Acceleration A is equal to B by T, that is 40 into 1000 by 60 into 10 meter per second square, and we get finally 66.66 meter per second square. Graphical representation of motion. Mm, This is the question, and we have derived this concept from the given question. Nature of the distance time graphs for uniform motion is a straight line. Nature of the distance time graph for non-uniform motion is curved line. A speed time graph is a straight line parallel to the time axis means object moving with uniform velocity. Area occupied below the velocity time graph gives displacement. Now equations of motion. V is equal to U plus AT, S is equal to UT plus half AT square, and 2AS is equal to B square minus U square, and we can also say B square is equal to, here it is in minus, and by changing its side it go other side and convert into plus sign. Now equation for velocity time relation. Friends, you should remember that when question is yes, you can understand by question. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second for 2 minutes. Find the speed acquired. Yes, you can understand. We have say velocity time relation means 2 minutes is time, and we have to find a speed, that is velocity speed, and 2 minutes is time. So we apply the formula as B is equal to U plus AT. We are focusing because many of the students unable to solve such type of problem. So you can again see this is the find the speed acquired, and we have acceleration and time. So we can relate a speed with time, and we conclude that this gives velocity time relation. Second, as seen, equation for displacement time relation. In this also question contains both displacement and time. Only we understand, we have to understand how can I use it. So you can see the question as a racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after start? Yes, what distance will it cover in 10 seconds? Yes, you can see that what distance, and this is the time. So relation between distance and time as S is equal to UT plus half AT square. S is equal to initial velocity as it is started from rest. So initial velocity will be 0 after a start. Yes, you can see after a start initial velocity will be 0, and final velocity, there is no need to final velocity, as formula is S is equal to UT plus half AT square. Initial velocity will be 0, and time is given 10 seconds plus half. Acceleration has been given, that is 4 meter per second square, and time t square 100. S is equal to 0 into 10, 0 plus half, and after calculation 1 by 2 into 4 to the 4, which will give 2 into 10 square 100, that is 200 meter. Now equation for velocity displacement relation. In this say question contain velocity and displacement both from both. Any of them will be given. See here, please see here. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone, and how much time will it take to reach? Yes. Now understand the question. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. Yes, in coordinate system, you have seen that upper part is positive and lower part is negative, and same right part is positive and left part is negative. So in upward direction, that is acceleration is in positive direction, and speed has been given, that is 5 meter per second in upward direction. The acceleration of the stone during its motion is 10 meter per second square in the downward direction. Please see here, in downward direction, that is it is in acceleration is in opposite to the velocity in opposite direction, so it will be written with negative sign. And what will be the height attained by the stone? We have provided velocity, and here what we have to find maximum height attained by the stone. So it shows a relation between height and velocity. So which formula we have to apply? B square is equal to u square plus 2s, or 2s is equal to b square minus u square. After putting the value, displacement, acceleration should be written with negative sign because downward. Here you can see during acceleration its motion is 10 meter per second square in the downward direction. So negative sign, 10 minus 10 into 2 minus 20, as if the displacement is equal to 0 square. Final velocity at maximum height, velocity along y-axis becomes 0. You should remember. And now minus 5 square minus 25, s is equal to 25 by 20, minus minus plus. It understood. There is no need to give extra time for this method, and it is understood. So s is equal to 25 by 20, that is after dividing we obtain 1.25 meter. Now, and the second part is how much time will it take to reach there. So we have velocity, and what we have to find time. So previous topic, previous point, we have read about velocity and time relation. So from that relation we conclude that time t is equal to b minus u, and acceleration here is in multiply, and after changing its sign in those which is in multiplication form went into division form. So it divide b minus u by a. Now time is equal to minus 5 by minus 10 is equal to 0.5 seconds.